Hello guys, today we want to look at substitution in logarithm, and the problem we have in front of us is given that log 2 equals 0.3010, log 7 equals 0.8451, evaluate log 112. So we need to first of all look for the factors of 112. So the factors of 112 are 56 times 2 gives me 112. Also, I can break it further. 16 times 7 also gives me 112. Now, I'm going to try to use this. And remember, 16 can also be broken down further as 2 raised to power 4. So, at the end of the factors making 112 a product of its prime factors is going to be 2 raised to power 4 times 7. So, I'm going to switch this into this. So, log 112 can therefore be written as log 2 raised to power 4 times 7. Yeah, 2 raised to power 4 times 7. So you also you recall that one of the laws we talked about, we said that when you have a product of numbers, it changes to sum, which is addition. So this is simply going to become this 4. Also, one of the laws is saying that when we have a power, it moves to the other side. So this is going to become 4 log 2 plus log 7. So now we can go straight into substituting our values. We have that log 2 equals this. So I'm going to slot it in. So it simply means that log 2 is 0.3010 plus log 7. Log 7 is this, and that is 0.8451. So when I multiply, I'm going to get 4 times 0.3010 is going to give me 1.204 plus 0.8451. So at the end of the day, summing them up, I'm going to get 2.0491. So that is the final answer. So we're going to take the next question quickly. The next question says, if log 2 in base 10 equals this, log 3 in base 10 equals this, evaluate this. So log 4.5 in base 10 is what we want to evaluate. So I'm going to try to readjust log 4.5. And when you look at it, you realize that I will not be wrong to say 4.5 is 45 divided by 10. Yeah, so 4.5 is log 45 divided by 10. Now I want to split this further. 5 goes here, I'm going to get 9 here. 5 goes up in here, I'm going to get 2. So this is simply broken down further into log 9 over 2 in base 10. Now, this is also the division law. So I can then decide to take the subtraction of this. So this is going to be, okay, let me write it here. So this is going to be log 9 minus log 2. But I can break this down further into 3 square. So this is going to give me log 3 raised to power 2 minus log 2. Also, log 3 square minus log 3 square is going to become 2 log 3. So this is going to be 2 log 3 minus log 2. Then we have that from the question, they said log 2 is 0.3010, while log 3 is this. So I'm going to substitute those values. Therefore, I'm going to be getting 2 times log 3, which is this, 0.4771 minus log 2, which is this, 0.3010. So what is that going to give me? When I multiply that, I'm going to get 2 times this is going to give me 0. Okay, 2 times, yeah, it's going to give me 2. 2 times 7 is 14. 2 times 7 is 14, again 5. 2 times, so this is 0.9542 minus 0.3010. And that is going to give me finally 0.6532. So this is my final answer. So very simple problems. I'm going to take another example again. This time the question says, given that x, equals log 2 and y equals log 3, express log the cube root of 72 in terms of x and y. So log the cube roots of 72 in terms of x and y. So I'm going to break this down to log, of course, 72 is going to be, cube root of 72 is going to be 72 raised to power 1 over 3. I hope you can see it clearly. It's raised to power 1 over 3. Then I can break 72 further to becoming log 8 times 9 is 1 over 3. So this is also, now I'm going to try to split it. This is also, this can be equal to log 2 raised to power 3 times log 3 raised to power 2, 1 over 3. Okay, then one of the laws of indices has it that this can multiply, this will definitely multiply the powers. So I'm going to take it to be log 2 raised to power. Now 3 times this is going to give me 3 over 3, while 3 times this is going to give me 2 over 3. So at the end of the day, these guys are going to cancel out. Then I'm going to be left with this. So I have log 2 times 3 raised to power 2 over 3. Okay, then you remember that the product law or the product rule in logarithm tells us that we are now going to have to add them together. So this gives me log 2 plus log 3 raised to power 2 over 3. And remember that we said log 2. Okay, before I do that, let me still break it down further. Log 2 plus, now this is going to be 2 over 3 log 3. Then remember we were given expressions. We said x is log 2. So that means I'm going to take this log 2 to become x, while it's going to become plus 2 over 3, while log 3 is y. So we have succeeded in expressing log the cube root of 72 in terms of x and y according to the question. Then the final problem we're going to solve today is saying, the question says, given that log y in base 10 equals to 2 and log 2x in base 10 equals to 1, evaluate log the square root of y in base 10 all over 3x. So this is also another very simple problem. What we just simply need to do here is to, first of all, try to say log square root of y in base 10 all over 3x. It's going to give us log, this is going to be y raised to power 1 over 2, of course, in base 10 all over 3x. Then the next thing we'll do, I'm going to move this guy to the other side so it becomes half log y in base 10 all over 3x. Then, so now that I have this expression, I'm going to keep it there and then I'll do something. First of all, look at this particular expression we have here. Say log 2x in base 10 equals to 1. So I'm going to do a kind of substitution. So let me write given, because we were given that. So I'm going to write given log 2x in base 10 equals to 1. One of the laws of logarithm, if you've not seen that video, please check in the playlist. One of the laws of logarithm has it that when we have log 2x in base 10 equals to 1, it can be changed to an initial form. So that becomes 10 raised to power 1 equals to 2x. Meaning that from here I can get to know my value for x. If 2x equals to 10, it simply means that x is 5. X equals to 5, because this cancels out, this here 1, this here 5. So the value for x is 5. Now that I know my value for x as 5, I'm going to substitute it into this expression. Now, also remember, this is what we simplified the problem into. Now I'm going to substitute my value for x into this, and also the log y in base 10 equals to 2. Remember, we're given that log y in base 10 equals to 2. So I'm going to slot them in. So what I have now, from half log y in base 10 all over 3x. This is now going to become half. Remember, log y in base 10 is what? 2. So I'm going to put 2 there. Then 3 times, remember, x is now 5. So this is what is going to become. So I am left with 2 over 2 all over 3 times 5 is 15. 2 over 2 is 1. So the answer to this problem is simply 1 over 15. Thank you.